Good morning, everybody. So I'm gonna talk about an almost fireball. It's an asteroid that kept me busy in the time frame January, February, and I just wanted to share a bit with you what I went through in those days. I have an honorary professorship at the Technical University of Munich. Honorary means you do it for the honor, you don't get paid. So according to the definition of Paco's questionnaire, I'm an amateur astronomer, right? Keep that in mind. And I proudly wear the t-shirt of my first astronomical association. This is me. And there's the meteor on the other side from where I look. Okay, so let's start. This is just a test. This is what I found yesterday when I realized this button doesn't always work. And I will give you the answer to that question. Who is actually testing near-Earth objects tracking software in the talk? Okay, this is what we would have seen in the year 2032 in December, so a few years to go, if this asteroid actually had continued its course that some people were thinking it had. And but let me start from the beginning. It won't happen, so don't be worried. This asteroid 2024 YR4 was discovered on the 27th of December last year. And it immediately made it to the top of the so-called risk list, which if you go to the ESA web page, there's a link here, NEOSSA ESA INT/risk list, or you use the menu item. It was on the top. The risk list, who knows what the risk list is? Circle. Okay, the official definition is it lists all asteroids with a computed impact probability larger than 0. So those are those we should be really worried about, not near-Earth objects. The definition is like they can still be 0.3 astronomical units away from the Earth. These are the ones you should be scared about. And amateur astronomers or asteroid observers should track those. There are 1,800 there, so it's not that many. And as you can see, most of the impact risks, it's this IP is like 1 over something horrible. So it's more likely that you win in the lotto games than being hit by such an asteroid. But this one actually, this 2024 YR4 made it all the way to the top. This is a screenshot from the day when it actually went above 1% impact probability. 1 over 30, 1 over 35 already means it's close to a 3% or something like that. So that was even a bit later. Now at 1% is the threshold when we have to start an official alert. And how does that work? Let me first show you the evolution of the impact probability. It was discovered in December last year. And then suddenly when, there were simply no observations done of this object in this time frame. And then some point in the middle of January, the impact probability started rising. That's already when I got calls from people or emails from people that follow this risk list on a daily basis. And they said, hey, Detlef, are you aware that there's an object that's getting close to these 1%? Why do I get these emails? Because I coordinate what's called the Space Mission Planning Advisory Group on behalf of the European Space Agency. That's one of the United Nations groups that deals with these things. But again, more about that later. So already here, I got these emails and I said, yes, of course, we are aware of that. We're following it. And then as the time came closer, that we really saw, okay, this is now the answer to the question, who tests this software? There are 3 different groups on this planet that do orbit computations and predict these numbers. One is at ESA, close to Rome in Frascati, where Paco is working. You'll hear more about the work of their group in the talk after the next. One is, of course, at NASA. JPL is doing work like that in the Center of Near-Earth Object Studies. But all this goes back to developments that were done at the University of Pisa, where there is a group, they call themselves NEODICE, Near-Earth Object Dynamic System, and they're still involved. They're more a a university type organization and do development on these systems. But all these three systems are in the end different independent systems. And when this impact probability rose above 1%, it wasn't computed by all three of these orbit determination groups. It was only one who said that. And that's when the daily telecon started and people talked to each other, which was annoying because JPL is in a different time zone. So, you know, in that week before it went above the 1% officially, I had to be in teleconferences at 6 o'clock in the evening, which is when I'm supposed to cook for my wife. So she had to suffer because of this, you know. All right, anyway, so that was just a few days, luckily. And then they all sorted out why there were slightly different values. I mean, there hopefully will always be different values in the end because they're independent software systems. So simply because of numerical differences, there should be slightly different results. But there were other things like, you know, how to weigh different observations. And when they applied all the same schemes, the same input parameters, then actually, yes, this was really consistent and we trusted the result. Now, what's the official alert system? This is what was agreed 11 years ago on the level of the United Nations. There are two groups internationally. One is called International Asteroid Warning Network, and the other one is Space Mission Planning Advisory Group. We pronounce this I1, and this one we pronounce the same page. Otherwise, you can't pronounce it. And I1 is simply a group of observers of these computer people that compute orbits that I just mentioned. There are also groups in there that compute impact effects. And their task is to determine the impact time of a potentially impacting asteroid and to find out where would it impact, what's the severity. I mean, if there's like a 1 meter object like those that we have, that we call the imminent impactors, where we saw the nice fireball photograph from Gijs in the breaks, that's not something you need to worry about. So we don't trigger anything. But if there's a certain size, in principle, I1 has to inform us about any object with an impact probability larger than 1%. This group here is a group where only delegations of spacefaring nations are participating. And they only get active if the object is larger than 50 meters. And then we think about, can we deflect the object? Can we send spacecraft there to do something against the impact? So turning this around, if the object is smaller than 50 meters, we will let it hit. And then any mitigation activities have to be done on ground, like evacuation, something like that. And let me remind you, 50 meters, if it's a rocky object, is comparable to the Tunguska impact. If it's an iron object, you get the meteor crater in Arizona. But still, it's like a cost-benefit analysis. It doesn't make sense if you do, you know, you spend billions for a space mission if you could do some work on ground. All right, and like I said, I'm chairing this group. That's why I was involved in all this. If there is an impact probability larger than 1%, we have to inform the international community, and this information goes via something called USA. That's the Office of Outer Space Affairs, which is like the secretariat of a group called COPUOS, and that stands for Committee of Peaceful Uses of Outer Space. They meet in February and in June every year in Vienna. And since many, many years, these groups here, I1 and Same Page, they also have their working group meetings in the margins of this group meeting in Vienna. So for us, that's very convenient. It's not very far to Vienna. So that's great. So this is what happened. The impact probability at some point was agreed by the orbit computation teams to be officially larger than 1%. Then I1 is required to give out this notification. And it tells you, okay, this is from I1. It's to the chair of the Space Mission Planning Advisory Group, and it goes to USA. And it gives you a summary of what we think could happen. Now remember, 1% impact probability means there's 99% chance that nothing happens. So it's not bad, and this is why it's not a warning or anything. It's just a notification. That's all it is. And then it says, okay, this is probably where it would be on the Earth if it were to hit. The most likely size range was 40 to 90 meters, and so on. So then, of course, the real work started. Then we again had regular meetings. I mean, immediately after I got this information, I called the steering committee of the Space Mission Planning Advisory Group, and we had a meeting where this is just additional information here. These are the telecons and videocons. These are the kind of things we were discussing. You know, I was shown all these nice plots, very colorful and beautiful. And then you have to ask people, what does it really mean? If you want to know that, you ask me in the coffee break. But that kept me quite busy. And this was then the official statement that we came up with. And that's what we were doing. Well, but that meant still that every day I was in touch with the people like from the NEO Coordination Center at ESA, with the NASA colleagues, to stay informed of what's going on. And then the cool thing was the timing of this asteroid was fantastic, because these meetings in Vienna happened in February. So just when it went to 3% or 2.5% impact probability, we all met in Vienna. And we were briefing the plenary. So all the 120 member countries of the COPUOS were informed immediately. They could ask the experts, what does it really mean? Would it really happen? What if you want to deflect it and it lands in another country? So that was quite good. And then this is just a screenshot of the document that we wrote. They have something called conference room papers, which is like an information mechanism where you formally inform all the diplomats that sit there, and then they go back and send this to the relevant ministries in their country. If you want to see the final version without all my edits here, you go to this link, and then it's public there. Of course, the press was reacting, and I have to say that was super positive. I was absolutely impressed. I mean, this is the Bild Zeitung, so they always have strange headlines like the Angst asteroid. It wasn't really an Angst asteroid, but okay, the rest of the information was really good. They compared the size with known objects like the Fernsehturm of Berlin, where you all know, of course, that the ball there is about 32 meters in diameter. Or who knew the wingspan of an Airbus? Anybody knew this before? I know now, it's 80. It's a bit smaller than the asteroid could have been in the worst case. But really, all the explanation there, it's really well done. I was impressed. All right, and then 3 weeks later, suddenly this impact probability, as you saw in the plot from the beginning, went down very quickly. So first it increased slowly, slowly, slowly. It almost reached 4%, and bloop, it went down. And this is the official notification. Oops, what happened now? Okay. Can you make me that full screen again, please? Sorry, I messed up here. So if you go to the web page of I1, you will see these notifications. And so that basically said, all right, forget it. No threat, no nothing, no worries. Impact probability went down to 0. So that's good news. Yeah, you can leave it like this. It's fine. So again, the press reported immediately, which I found very good. There were very few of these stories, oh, we will all die, luckily. So I think we made some progress also in communicating this potential asteroid impact rate. So unfortunately now what you will not see is a nice fireball. And believe me, the final size that we now think it has, based on observations with the JWST space telescope, it's going to be about 50 to 70 meters, 60 meters plus minus a few meters. That's the value we have now. You don't want to be there and watch the fireball. You want to be far away, right? So we would have attempted a deflection of this object, but that's not needed. The cool thing is, oh yeah, let me first explain why does the impact probability rise, and then drop so quickly. If you could start the little animation from me. This is the uncertainty here. that's the moon's orbit. And the red dots are the uncertainty. So of course you compute the impact probability by looking at the area that the Earth cuts out of this uncertainty. So as the uncertainty shrinks, it rises until the uncertainty drops off the planet, and then it immediately goes to zero. But look at where the most likely impact location is now. It's close to the moon's orbit. And that's the cool thing, that we now have a 4% impact probability on the moon. Yeah, so remember my presentation from last year where I said we should also consider looking at lunar impact flashes. That's really helping us understanding asteroids. If you get, radar observations before we know precisely the shape and everything of this asteroid, and then we see the impact flash, it will be probably bright enough to be visible even in front of the illuminated part of the moon with the naked eye. I mean, it's a 60-meter object, so that's quite significant. That would be nice for some of us. Of course, the space agencies are worried, oh, what happens then with my spacecraft? Will they be impacted by the ejector? So this is the brightest flash observed so far, which left a crater of tens of meters in diameter, but it will be much, much brighter. I mean, don't use your video camera. It will be just overexposed unless you put some kind of neutral filter in front. The thing is, the asteroid is not observable now anymore until fall 2028. So I might give you an updated presentation then in 3 years from now. Thank you very much.
Online-Teilnehmer von morgens letztendlich 11 bis abends 17.
Thank you, Detlef. We have some questions.
Für das Wochenende, für heute, haben wir, denke ich, ein sehr dichtes Tagesprogramm.
Is it still possible to calculate the position of the impact on the moon now? Is it on the front side or on the back side? On the back side, we will be set.
Well, this is why I showed this diagram. That's the position.
Oh, really?
The green dot, the blue dots, or whatever color that is. So there's a few of the dots are on the back side, but like 95% are going to be visible from the Earth.
Oh, great.
Bei Krupp eine Abteilung Krupp-Antennentechnik, und diese Krupp-Antennentechnik existiert bis heute.
Good, thank you.
No, there's one more question, Sebastian.
Und man baut wieder 20 Meter Parabolantennen dort, und wir werden etwas vom Hersteller sozusagen.
Thank you very much, Detlef, for this talk. I was curious, if it is impacting the moon, what are the probabilities of getting peppered by any ejecta that might be reaching our planet? And
12:45 Uhr, das ist durchorganisiert für alle.
Read Paul's paper. Yeah, he published a paper on exactly that topic in 2025. Yeah, so there is a small chance, but it's going to be again long time in the future. So wait a minute, here we have this was more than 10% of the ejected material would accrete onto the Earth on a time scale of a few years. So yeah, there will be some stuff coming to the Earth.
In die Runde fragen, wer ist heute Abend
some other questions
und nimmt an dieser Abendveranstaltung teil, und für wen soll ich das Essen mitbestellen?
One thing I don't quite understand is, so it says it's a 4% chance of the impact. When you show this image of the moon, it looks to me like sort of all the distribution of probabilities are basically on the moon, or is that just that part that you're showing?
This is the misleading thing, which why I don't like showing these impact corridors. What Bill Gray didn't do is he did not show the paths outside the moon. This is why I prefer showing this picture where I showed you the complete uncertainty. So that's just, these points are only those 4% that will hit the moon. It's not 100% of the positions. No, it's only the 4%. It's even a bit less because some of them on the backside of the moon. Yeah.
Und ja gut, eine Sache machte mir Sorgen.
So even if the asteroid don't misses the moon, we can see it in front of the moon passing it, or it's on the backside passing it, or can we say it at the moment?
Yeah, there will be some of them, some of the clones that they computed, there will be in front of the moon. Yes.
Great.
Then the question is, how it's going to be close to the moon. It's going to be 60 meters in size. So you need a big telescope for that to resolve it.
You mentioned that if the impact probability would increase towards the Earth, it would trigger a deflection scenario. So what would that be?
Yeah, okay. We did not look at the deflection scenario in this case in detail because we now can 100% or 99 point and then put 7 nines behind the decimal point. We know it's not going to hit. The first initial thoughts that we did was it would have been tricky because we know nothing until 28. The impact is in 32, so it's very little time. Now, the question we were asking is, what if we had, say, more than 10% impact probability at the end of this year's visibility period? We would definitely have recommended to prepare for a deflection mission. So do phase A, phase B studies, all the space agencies have a spacecraft design ready. So then if in 28 we confirm the impact, we could have very quickly built a spacecraft or even repurposed a spacecraft. You know, there's this Comet Interceptor mission. I mean, could have intercepted an asteroid. It's going to be on the launch pad in 28, 29. We would probably have suggested to hijack that mission and just send it there instead. So, but, you know, the detailed scenarios, we didn't look at that much for this particular case because there's no worry. It is very challenging. It has to be done for each individual case separately. They're all different, unfortunately.
Thank you. Let's
Okay.
thank Detlef.